patterns of it.
Perfect. Yeah. So it's small. I'm actually a lead developer executive at HERE. HERE being part of the story that I'm going to be telling today. Did anyone come to my meetup when I was working for Couchbase? I come down to this meetup group every once in a while. No, first timers. All right, perfect. So the theme is going to be around Raspberry Pi. It's going to be around JavaScript, and it's going to be around some HERE products. So in particular, HERE XYZ. I'm going to get down into each one of those. We're going to see some code. We're going to see some demos, some cool stuff that you can do. So the agenda, three main parts here. So we're going to look at interacting with the Raspberry Pi. We're going to look at interacting with the hardware that I brought. We're going to look at parsing GPS data. So I brought a GPS with me. And then we're going to work towards getting that data into HERE XYZ so that we can understand the APIs, and then later access that data in our front-end web application, which is JavaScript. So JavaScript on the Raspberry Pi, JavaScript on our client-facing application. So we're going to see a lot of different things. Did anyone happen to see the tweets that went out regarding the link that I posted up a couple times, maybe? So I actually posted that link. So I drove down here from Tracy, and I actually had my GPS running, and it was collecting the data for my drive, and it was publishing it in this web application, which I'm going to show you. It's a little chaotic, the web application. I think I had some bugs in my code, but the data, I double-checked it later. The data is correct. We'll work through it.
On Twitter?
I think I put it on Twitter. I think I also put it on the Discord channel, right?
That's what I saw.
Well, what's Twitter?
It's all good. I'll share the link. We can look at it together and see some of the chaos that I did. So the first part, Raspberry Pi with JavaScript. And you feel free to stop me at any point in time if you have any questions whatsoever. So the hardware that I brought with me, and those are crude renders, but Raspberry Pi Zero and a uBlocks Neo 6M GPS module. So the Raspberry Pi itself, I'm using the Raspberry Pi Zero W. So this is a $10 version of the Raspberry Pi. It runs ARM. It runs popular versions of Debian. So Raspbian is a popular version. It works off of a micro SD card. It's pretty easy to use, especially at that $10 price point. The GPS module, so again, the Neo 6M GPS module, they range online between $10 and $30. The cheaper of the bunch being the ones without the pins. So if you feel comfortable soldering your own pins to the GPS module, you can get it a lot cheaper. I think I paid $20, $25 for this one. It came with the pins already attached. So not that expensive. I'm just connecting the two with jumper wires. So these are 10-cent wires. Pick them up at Fry's anywhere. Doesn't really matter. So the two are connected that way. I did have to solder pins onto the Raspberry Pi Zero though. But if you're uncomfortable with that, there's always versions of the Raspberry Pi where you can buy it for a little more of a premium that come with the pins already attached. But my story is, for $10, it taught me how to solder. So I didn't know how to solder prior to this, and I was able to figure it out with these cheap little devices. But when it comes to hooking up the two devices, so the Raspberry Pi has about 40 pins on it, at least this version of it. The Neo 6M has 5 pins on it. You only use a fraction of the pins on the Raspberry Pi. So in technology here, there's a VCC pin on the GPS module that represents power. You hook that into the 5-volt power on the Raspberry Pi. Each pin on the Raspberry Pi does have a true meaning, and you can find a template for it very easily online. Ground wires, you connect the two, and then you invert the TX and the RX. So the RX on the Raspberry Pi will go to the TX on the GPS, and the RX on the GPS will go to the TX on the Raspberry Pi. And that's all there is to it when it comes to connecting it like that. Now, once it's connected though, it's not ready for use. You can connect it, it's not going to do anything. It'll light up, it'll turn on, but it's not going to interact. So you actually have to configure it. And if you're using the popular version, Raspbian on your Raspberry Pi, it does ship with a configuration tool. And the whole purpose behind this is you need to enable the serial connection on the Raspberry Pi through the software. It's very easy to do. Using the command line, you would say sudo, and then you would say raspi config. You would bring up a screen that looks like this. You would choose interfacing options. You would choose serial. And when you choose serial, it's going to ask you two questions. The first question is, do you want to enable login over serial? You can. I generally don't. I usually just SSH into it rather than logging in through, I think the command is screen if you're using a serial connection to log in. So it's up to you. The second question is, do you want to enable serial for hardware connections? That one you answer yes, definitely, because you wanted to be able to interact with the hardware module that you've connected. And when you do that, it's going to spit out something that looks like this. So if you do a cat on the serial port on the Raspberry Pi, which is TTY-S0, it's going to dump out this craziness. So this is actually a spec. This is a GPS spec. It's called NMEA, and it's a comma-delimited line. So each line is a full set of data. Some of the data, depending on your GPS module, is going to be irrelevant. This particular GPS module, the relevant pieces of data would be the GPRMC, and then the GPGGA. And those types of lines, as denoted by the first column, represent, well, what kind of data are you receiving? You're getting how many satellites did it find in the fix? What's the latitude and longitude? When was the last hit against the satellite made? Different information like that. So it's an actual spec that you can parse yourself, or we're going to use an actual library to do the parsing for us. So it's not bad. But if you run that command and you get something like this, this means that your GPS hasn't found signal yet. So this, being as cheap as a GPS as it is, it's not going to be instant. It's definitely not going to be the best GPS you can buy. So if I were to plug this in right now, this GPS probably wouldn't find anything because we're in a building. I'm not close to the window. I don't have an antenna hooked up to it. You don't necessarily need one for this. It has one built in. But it does have a connection port on it to add a passive antenna. So a much more powerful antenna, which I actually have in my car. I left it in my car. But depending on what you're doing, if it's just like this, it'll probably take, if I was outside, maybe 15 minutes to get a signal. If I hooked it up with my actual antenna, maybe a minute. And then the accuracy is decent on this particular module, but of course if you buy a more expensive module, it's going to be a lot faster, a lot more detailed. It's totally up to you on what you want to accomplish with it. But if you give it time, it'll start spitting out data that looks more like this. So to engage, so with Node, because we're all JavaScript developers in here, right? To actually engage with the serial port on the Raspberry Pi, or even on your laptop. So you can actually, if you have a UART cable or a UART cable, serial cable, it runs by many names, you could actually hook this directly up to your laptop and use it through a serial connection on your laptop. You can get that cable, it's like $5 online. So you could actually run a Node application on your local computer or on the hardware itself. But you would install this serial port application, so this package, and that will allow you to engage with the serial connection on your device or computer. And to use it, what you would do is you would import, first of all, the package. You would define the port that you want to use. On the Raspberry Pi, it's generally going to be TTY-S0. If I were to use it on my laptop, it's like USB slab something. It goes by various names depending on the drivers that you've installed. And then you would set the baud rate, which for this device would be 9600. You would create a new parser, and then you would listen for events. In this case, you would listen for lines of data coming in. For each line of data, in this example, I'm choosing to just print it out. And that would give me the same results as if I were to say that cat command. So cat and then whatever that fire hose of data is spitting out. Does that make sense so far? Got it. Next up, because I've tried parsing NMEA for metadata. It works, it's not pleasant. It's a lot easier just to install a GPS package. So when you install a GPS package, you just pipe in that data, that raw data, it's going to spit out something a lot more pleasant. So in this case, in order to set that up, well, we already have our parser for the port. Now we're passing in the data. So I know that the comment is a little faint based on the color contrast here. But let's say we've got that line of relevant data. We call GPS.update, and then that GPS listener parses that data for us. So we're checking to see what type of data it is. again, this particular GPS GGA or RMC. Otherwise, we just ignore whatever else is coming through. And then we print it out, but it's going to be a little more human readable. So it's going to have lat long, it's going to have the number of satellites, the type of data, a bunch of other stuff that I can't remember off the top of my head because I don't typically use it. But it's a lot more easy to use in this circumstance. Now, when working with GPS data, lat long is typical, but when working with GPS data in more realistic scenarios, most people in the location services space, or depending or the ArcGIS or Esri space, they're using a different type of format. It's called GeoJSON.
When you go back to where are you picking up the actual data? Like, where the one that's worth it is the GPRMC, right? Where are you picking up only that data?
GPS.
Yeah, so GPS.update. So the parser is going to be receiving the pipe of basically that serial port is just going to fire it in.
It's going to give everything, all the junky data too.
Yep, all the junky data. We call GPS update, so it passes all that junk data. Doesn't matter what it is, it passes it into GPS, and then GPS parses it, and then at that point, after it's parsed,
then we say pick only this one.
pick only that. Yes. Does that make sense?
Does it actually process the checksum and won't deliver it? The checksum doesn't.
I don't know. It's a good question. I honestly no
I
idea.
just because I saw that you already have that data, like the right data, but that's the whole screen. At that point, you just pick up everything.
Yeah, it's just line by line.
Yeah, okay.
And I mean, you could always build your own serial parser as well. But what I found is it doesn't necessarily give you that whole line. So you end up having to construct your own full line. Otherwise, parts of that line is kind of irrelevant, it's broken. So it's best to use this parsing library with serial port. So like I was saying with GeoJSON, so this is a spec in the mapping industry, in the geolocation services industry, which is very large. I don't know if anyone's been exposed to this kind of space before, but GeoJSON is a thing. It's just a extension to JSON. It's still normal JSON data, it just follows a certain spec. And that spec includes features in a feature collection. And features represent geometries. So in this case, this is a simple point, but you can have geometries that are much more complicated, like polygons and things like that, stuff that's meant to be rendered on a map. So we're going to be working with only point data, but this is the type of format that we're expecting to work with, rather than just that raw latitude and longitude information. And lucky for us, Node being as green as it is, we do have a package for that. While it is still JSON at the end of the day, it is always a little more helpful to make our lives maybe 10 steps a little easier, and it'll automatically create that in the proper format for us. So let's take a look at this example now. Let's say that we've taken in the RMC or the GGA formatted data that we want. In this case, we're creating a points array. We're only going to have ever one item in this example in that points array. Lat and long. So this is the data that's parsed out from our GPS data. Then we say GeoJSON parse. We provide that points array, and we're also providing a mapping of what the latitude and longitude is for the point. So in this case, lat and long represents the object properties, lat and long. So it'll be different depending on what type of geometry you're using. But for points, that's what we would do. If I were to print it out, it would again look like it would look a little bit more like this. So again, it's not too difficult to reproduce that, but it is a step that we don't have to worry about. Now let's look at HERE XYZ. Assuming that we've got this whole Raspberry Pi thing down, I mean, there wasn't a whole lot to it. We've enabled the serial connection. We've taken in that stream of data. We've parsed it as GPS. We've converted it to GeoJSON. Now we need a place to put it. So this is a HERE product. It's based off of a freemium model, so you get a certain number of transactions for free every month. But HERE XYZ, I like to think of it as two different categories. So one, it's a kind of a hub for your data. So a cloud management tool for your data. So rather than having to spin up your own database, You can push your geolocation data directly into it, and then access it through APIs. Another aspect of it being a data visualization tool. So if you're not necessarily a developer, which we are all developers here, if you're not a developer, you can easily visualize that data without having to know how to code. So I personally use it more for the data hub than the data visualization. Analysts might be more into the data visualization stuff. So what would happen is we create a new space in HERE XYZ. This space is going to represent like a bucket for all of our GeoJSON data that we're collecting with the Raspberry Pi. And I'm going to dive into that. I'm going to show you what my Raspberry Pi collected. But you would create a space, and then it will spit out a space ID. You'll generate some tokens for it, and then if you wanted to, you could immediately visualize it in the visualization tool. This is old data. I have new data to show after this. But this is an example of what it might look like if I was just uploading points. This is not actually a line. It's just a lot of points that are closely spaced. So it kind of looks like a line. But it could be a polyline if I wanted it to based on the GeoJSON. So let's look at uploading it to XYZ. So it offers REST APIs. So say we create an upload to XYZ kind of function in Node.js. So this would exist on the Raspberry Pi still. Because we're collecting it up until now, it was just going into the void because we're not doing anything with it. But this is an enhancement to that previous example of creating GeoJSON data. So with GeoJSON, you can add other properties to your GeoJSON. So this example, I'm including the lat and long that represents my point. I'm also including, say, a timestamp. I'm including latitude and longitude spelled out in full. And the reason why I'm doing that is because they're going to represent kind of meta information in XYZ. They're not relevant in the sense that they define what your data is when you're trying to use it. It's more meta information for when you look at XYZ, you can make sense of what that information represents. So in this case, it would show latitude and longitude versus just being invisible. It would also show the timestamp of when you've uploaded and why that's important. So having the properties, having these tags, it allows you to segment your data kind of like an index in a database. So if I were to do a GET request on my XYZ space, if I didn't have any kind of tags in place, I'm getting all of that data back. And in a realistic scenario, you're probably going to have maybe gigabytes or terabytes of data. I don't on the Raspberry Pi example, but you could. So by tagging it, now you're saying, you know what, depending on how you set up your tags, maybe give me all the data from the last hour or all of the data from yesterday. So that way I don't have to worry about getting 10 terabytes of data. So let's say I create my GeoJSON, I parse it out, I create an object out of it. I've chosen to use Axios. Has anyone used Axios before? Yeah, so Axios is just an HTTP library. You can use fetch, you can use request, you can use something else. Just a way to do an HTTP request. I'm doing a put request here. I'm doing a put request to the HERE XYZ API. I'm defining my XYZ space. Let's imagine that I've defined it in a variable somewhere. I've also defined an XYZ access token somewhere. So an access token, you give it kind of permissions. So in this case, if you want to put data, you would of course need write permissions. But then in the front end application that I show you, maybe you only want it to be read permissions. So that way nobody can view your source code and then do some malicious stuff to your application, if that's the case. But so we push it up, and then it exists in XYZ. So we've got it in XYZ, and I'm going to show demos coming up. But now we want a way to display it. We have come to the conclusion that maybe we're developers. We're not too interested in using just that core kind of data visualization tool that XYZ offers. We want to add our own spin on it, make it really neat. So we decide that we want to create our own interactive map that consumes that data. So this is where HERE location services would also come into play. So to use this, it's a different developer portal with two different products within the company for now. But you would create a developer account. It's free, there's no credit card required. You get 250,000 requests for free every month. And then depending on whether you added a credit card or not, it would just stop. And then it would reset the next month. But with that, we could add an interactive map. So this is a separate application. This application would exist not on the Raspberry Pi. This would be somewhere that you host somewhere on the web, maybe AWS, Netlify, whatever you're comfortable with. So you add the JavaScript libraries. It's a very modular SDK. So you add the features that you want. In this case, we have the core mapping feature and services. So that way, maybe we want to use geocoders or something like that, we could. We initialize the platform. So the platform is going to take a JavaScript API token. And when the platform is initialized, then we can choose which particular features of HERE we want to use. So the platform is not the map, it's the platform to any of the APIs. So in this case, we're saying we want to use the mapping feature, the interactive map of the platform. We're saying that we want to fill it inside of a placeholder component that we created with ID of map, because it's rendered through JavaScript, it's rendered after the page loads. We're saying that we want it to be a normal map, so this would be a daytime map, kind of what you would expect on your phone or common devices. You have the option, you can choose satellite maps, terrain maps, dark mode maps, weirdly contrasted maps, or your own custom flavor of map layer as well. So it's totally up to you. This would be the most basic kind of example of a map. We would set the zoom. Zoom is anywhere between 1 and 20. This would kind of be zooming over, a 10 would be maybe 2 or 3 cities. And then we have a center point, in which case this is Los Banos, California. So that's just an example. Now, to interact with that map, to add objects to it, this isn't any particular API or anything. This is just object features of a map. So maybe you want to add a polyline. So a polyline would be just any kind of line. In this case, this would be a straight line with a start and finish. Very basic example. But what you do is you create a line string. A line string is a representation of either a polyline or a polygon, depending on if you want to have a fill region in your shape. So this being a line, it's not going to have a fill region, it's just going to be a line. We add some points to it. Then we add that line string to a new polyline, and we define whatever style information we want. So in this case, it's line width of 5, so it's a little more visible. You can set the color. You can set a lot of cool stuff. You can make it dotted. You can do whatever you can think of as far as what's available as far as the styling goes. Maybe we want to add some markers. We create a new marker. We add the same position information here. Now you have a marker at each end of that line. Then you could add objects. So I've done it 2 different ways. You could add one object with add object singular, or you can add an array of map objects with objects plural. So it's totally up to you on what you want to do, whatever makes sense. There are a lot of APIs that you can use with HERE, and I realize it's a little small, but I can always share my slides later. But there's more than 20. They're all part of this freemium package. So it's not just maps. It's not strictly a visualization kind of feature. There's geocoding where you can give it addresses and it'll give you coordinates. There's complex routing, so you provide it a series of waypoints, and it'll calculate an actual navigatable route with turn-by-turn directions if you want. Whatever you think of as far as location goes, there's probably an API that HERE offers on the subject. Now, let's say we want to consume what's in HERE XYZ. So again, this is still in the front-end application, the one that we're working on outside of the Raspberry Pi experience. In this case, I'm still using Axios, keeping it consistent here. It doesn't have to be, you can use one of the other options. But we're doing get. I'm assuming again that I'm using a different access token because this is exposed to your end user. So you don't want them to have a write access token and they erase your entire XYZ space. So definitely pick your tokens wisely. But the actual request is pretty simple. And if you wanted to use tags, so maybe you created tags, you could add query parameters to specify the tags that you want to query for, to only consume that data. Now, let's kind of bring it together now. So we make that request with Axios. So we get a feature collection back. So this is GeoJSON. We're getting that feature collection back. So our goal is to create a line string on our map, or a polyline, that shows our actual path of travel, or whatever data we've collected. Your data in XYZ, it doesn't have to be an actual route. It can represent whatever you want it to represent. Maybe you're surveying trees in the national forest. You probably don't need a polyline to connect the dots, but it's up to you. In this case, I'm saying this is a route that I've navigated. So I loop through each feature in that collection. I extract the latitude and longitude. I add that line string to a polyline, and I add it to the map. Maybe I want to add markers at each end of that polyline. This is a complex polyline. There's more than 2 points in it. So it's going to actually represent a route. Maybe I want to add my markers to it. So I would get the first point from the polyline and the last one. I would recenter the map. So I can use this set look at data, and it would set it so that way that whole polyline is within the bounds. Because if I have potentially a lot of data, and I have a zoom of 10 and a specific center point, a lot of it's going to be cut off. So I'm recentering the map, I'm resuming it, so that way everything fits. So this is another example. This isn't a live example of what I did today, but this is an example of something I did in the past, where I actually drove a route and I picked up data that was an XYZ. Now I didn't want to show you what I actually had in XYZ today, and like I said, I think I had some kind of bug, because my map looks nuts. It more or less got me where I needed to be, and I looked at the data. I'll show you the data in a second, but this is a little wild here. So let's go look at the actual XYZ Studio visualization tool. So these are actual points that were being pushed up from my Raspberry Pi as I drove here today. So it looks like my data is accurate. It doesn't look like that crazy map I just showed you. So more, it's probably a bug in some sense that I've done. It was last minute. Hopefully I can correct it tomorrow before my next meetup. But it's really cool to be able to do that with such, I mean, less than $40 worth of hardware and just a few less than 50 lines of Node.js. I was able to accomplish something like that. So the Raspberry Pi is a great experimentation tool for something like this. If you're just getting started into hardware or even software, I think it's a pretty neat project. As far as what this data looks like though, in XYZ, it would log me out maybe. All right, let me log in real quick. So the data hub, so this would be my space that I used. I actually don't know how many records it created today. So a little over 14,000 points were submitted today on my drive. But the data that you see here, these are the property data. So the actual lat and long, you wouldn't be able to see in this dashboard. It would be hidden to you. You'd only be able to consume it through an API call or through the studio. But that's why I added the actual latitude and longitude and the timestamp information, so that way I could actually see it if I really wanted to, which I probably won't want to, given how much data is there. But I think it's pretty interesting.
I think I kind of missed it when you were talking about, is the initial data actually stored in the Raspberry Pi, or is there an actual HTTP that brings it?
Yeah, so in my example, and it could be totally different for whatever your use case could be. So my data is collected, not stored, it's immediately pushed up.
And that's where HTTP came in?
Yeah.
Okay, I kind of missed it.
Now, if you wanted to fancy it up a bit, and that's something that I didn't do, what I could do is I could store a little bit of it on the Raspberry Pi, maybe push it up in batches, or who knows, whatever you can pick up. It probably makes sense to push it up, because storing it on the Raspberry Pi probably won't have much utility to it.
What was the module again that did the HTTP request?
I'm using Axios.
Okay, Axios.
But you can use whatever your preference is. A lot of people use request or request promise, or if you're using front end, fetch would work in modern JavaScript.
Did you just tether the Pi to your phone?
I did, so I broadcast. I mean, you don't have to. So in my case, I did set up a hotspot on my phone. The Raspberry Pi does have LTE modules that you can purchase, but but I don't want to pay for another plan. I think you might be able to do it with AT&T for like $2 a month extra. I don't know what it costs for it. Probably the same as a tablet, right? Anyone have LTE on their tablet? It's probably cheap, but I didn't want to go through that hassle.
No reason.
If you wanted to do something cool, I mean, that would certainly make the project a lot more interesting if you had your own LTE module on it. But yeah, I mean, I'd be happy to. Let me just close this out. I'll be happy to show more examples or answer questions. So I just have links here, and I'm actually hoping for questions and stuff. This is if you wanted more help. You can go to developer.here.com. I used, of course, just an interactive map as my example and XYZ. You could totally enhance your project. So there's an API called the Route Matching API. So if I was driving, I don't know, kind of not really on a road, or maybe this GPS module wasn't quite sure where I was because it's not an expensive GPS module, I could use the Route Matching API, provide it the latitude and longitude coordinates, and it's kind of like if you're ever using a Photoshop tool and you're using the magnetic lasso, it kind of fixes your points so that way they're on an actual route. So I could clean up my data that way if I found my data to be maybe invalid or inconsistent. So there's a whole lot of other API use cases that you can do.
Yeah, can you post these links to the Discord later?
Yeah, for sure. Can I upload my slides there too, or is it?
Please do.
Will it accept it? I think it's like 14 megs.
Probably won't accept that. Talk to DJ and he'll find a way to do
Sure. And I show you, I had anticipated to plug this thing in, but you know what? I only have one adapter, and it's being occupied by this presentation tool, so I kind of changed things. But it's all right though.
That's a serial.
What was that?
What's the format of the adapter?
A USB-C to USB-A adapter.
That's an Apple, right?
Yes, it is. So we could try to actually connect to the Raspberry Pi and see what's going on.
Which map did you use for the, you guys did create your own maps?
Yeah, here creates its own map. So they have a fleet of LiDAR cars around the world that are collecting map data.
Oh, is that the one, oh, really?
Yeah.
Oh. There's a whole system of LiDAR that we have access to?
No, these are LiDAR cameras on the vehicles that HERE owns.
Oh, okay.
Yeah, so they're driving around constantly in different countries,
And you can,
and they're collecting 3D data.
Wow.
And we have a team of cartographers. It's a different space. I'm totally not in that space, the developer space. There's a whole map making part of the company where they're actually creating the tiles and things like that.
That's interesting. They're not just buying it off Google.
No, they're not.
And the reason for that is this is a competitive space.
It's competitive space. I mean, somebody brought it up. I forgot who brought it up. They mentioned Nokia. So I mean, here used to be Nokia, but even before Nokia, they were Navtech, which existed a lot longer than that. So they've gone through different names, but they power a lot of other devices like Garmin's and most in-car navigation systems. If you have purchased a navigation system in your car.
Any off-road products?
I don't know. I don't know the whole product line, but probably. They're in a lot of hardware. So let's see if I can get this connected here.
So officially GPS data is accurate to what dimensions?
So it depends on the GPS.
But definitely it's accurate to within like houses, right?
Yeah, some of them are like less than a meter. This one obviously is not, but like if I sit in my house and leave this thing on, it keeps detecting stuff like.
Well, there was an application that I needed to keep track of people who put door hangers.
Yeah.
But I just kinda.
It could work, I mean-
Yeah.
It was accurate enough. I mean, I've hooked up this thing to a battery pack and attached it to my bicycle, and it did a decent job. I mean, so what a cool feature here that I've done also with the Raspberry Pi, different from this, but similar. So here offers positioning through other circumstances other than GPS. So for example, you can actually calculate a relative position based on wireless network access points. So if you collect several wireless network access point SSIDs, those actually have a location associated with them. Not a lot of people know. And you can triangulate enough your actual position just through not even connected to a Wi-Fi network, just being around in a Wi-Fi network, you can figure out your location. So it's
Actually,
interesting.
all I would need is a certain location and a certain time.
Yeah.
Time frame to know if the bag actually just
Yeah.
through the.
Yeah.
If you just like, take a certain amount of seconds, I think that's just the data that I can work with.
Yeah.
But all the GPS data is timestamped, right?
If you choose to timestamp it, you don't have to.
I mean, it comes in the raw data. It's got a timestamp on it from the module.
Yeah, in the module, it has when it, yeah.
So, $40.
Yeah, it's cheap. I was impressed. I always thought that the GPS modules were a lot more expensive. Like I said, I've used it with a serial plug. Again, you can pick them up for like $5 on Amazon. I've also attached the same module to my Arduino, and it worked as well. So it's pretty diverse, I guess. Although they all might be. I don't know. I've only ever tried this one. So let's see. Let's see if I can actually share my Wi-Fi here to the device. Anyone good at sharing devices with hardware and Mac? Or internet with hardware? But generally what would happen if I was on the same network, because I had to use a guest network to connect here, so I had to enter a username and password. Generally I would have them both on the same network. But if I switch this to my hotspot on my phone, then I might lose the connection with this thing. It's going to create a little bit of a mess. Otherwise, if the network didn't have username and password, it would probably be better. So I apologize for that. But generally, what I would show is I would show logging in. I would show what that data looks like when it's dumping out. This light's not blinking. That means that it's not found a fix. Once it starts blinking, then it has a fix. So it'd just be dead data kind of. Any other questions? Anyone have any experiences with Raspberry Pi? I heard one had a Raspberry Pi 4, right? But I haven't touched it yet.
I turned it on, installed Raspberry, and that's about it.
Yeah. They're really cool, and for the price, they're great to experiment on. Yes.
I was actually interested in the data visualization. I know I came in a little late, but I don't know if you actually touched on that.
So I didn't touch on it very much because I personally don't use it a whole lot. Because I generally, when it comes to the using XYZ, I just create my own map project and consume the data. But I mean, maybe I can answer your question. I can try it.
So I guess one of the things I was interested in within the data visualization is like, you know how Uber, I guess when the car is coming to you, and you can actually visually see in real time that the car is moving.
Yes.
I don't know if that's a part of the data visualization.
So in that circumstance, just using XYZ Studio like this, it wouldn't be enough because you would have to add your own business logic to it. In that case, you would use just a HERE interactive map. You would consume the data. You would add your own kind of logic. You would probably refresh on an interval and
Or a website.
update the custom markers, which probably look like cars, right?
Okay.
So in that case, you would need some development to go along with it. But if you're, say, mapping earthquake data, where you have collected all of this data, you could even collect sample data sets on Kaggle if you wanted to. And this tool would make sense for that because you're just looking at the data that you've collected, because just raw latitude and longitude data for an analyst, that's not going to help them at all.
So what's the quote unquote real time? What is real time about?
So I kind of faked it on this one. So real time. So there's no real time yet. You can do near real time. So if I wanted to in my code, what I could do is I could use the set interval function for JavaScript and have it refresh the map on an interval. There's no WebSockets or anything yet. It's going to come. Until that happens, you can't really say it's truly real time.
So how does that compare with the System?
With which?
System.
I've never heard of that one before.
Okay. So we have a flight simulator, and we use, the model generates a landmark position, altitude, and we use, at one point we used System when it was still free. And after switch to the high-def 3D stuff, I was thinking,
So there's actually a demo on it. It was taken offline. I gave it at CES last year. Well, this year. We're still in 2019. But there is a flight traffic control demo that existed at one point where it
the
took
flyware,
which
the dongle, to
No,
capture the
so-
ADF,
so there's an open data set that the airline industry has.
ADSB, right?
I think that was it.
Yeah.
So using 3JS, has anyone used 3JS before? Yeah, so using 3JS, you can create a globe based on some images, and you can show kind of a simulation of the air traffic.
Right.
And if it was being piped in real time, you could in theory show the planes wherever they are in the world, and you can show all that air traffic information. It was a cool demo.
Uh-huh.
It used old data. It wasn't real time, but it could be if you were receiving it in real time, because at the end of the day, it would be near real time, but you're developing that business logic. Things like
Air
3JS.
traffic data is available?
Yeah.
Wow.
Yeah.
These things.
Yeah. But I mean, there's tons of use cases. I've heard use cases people want to do first responder stuff with this kind of stuff. Probably makes sense for train systems or.
You can get a ADSB dongle hooked up with the Raspberry Pi. It's like maybe $200 the whole set. It comes with an antenna, and when you hook it up, you power it up. You become a data contributor. So they're collecting data from all the dongles all over the world, and we're compiling the data. So
But that's just the mechanics. I guess all the air traffic controllers have to give out the data or whatever. Somebody has to. the data
no, each plane now
Oh,
they're
each plane
required.
has it. Okay.
They're required to carry
And it's
ADSB
required to
tags
send
on
it to
them.
a certain point where we have access
Right.
to it. Okay. Basically, every car have that too, that Westonian, right?
Yeah, so I mean, so I don't know if anyone's heard of smart. So it's not the smart car, the smart vehicle. There's actually an API service called Smart Car. So smartcar.com. So I guess they have some kind of partnership with a lot of auto manufacturers, and it's weird stuff. It's almost scary in a sense, but they can integrate with your vehicle directly, so they can unlock your car and view where you are on the map. It's weird, but apparently that's accessible through APIs.
Wait, man, we need to ask what farmers is doing with all this stuff.
You know how fast you drive.
Seriously, right? I mean, geez.
You guys okay if I take a selfie for Twitter? Or-
What's Twitter?
Should we smile?
That works.
So when you're in your car, you got everything going, and something goes wrong. How do you interface with the Pi for your display? You know what I mean? Like,
Yeah, so I very rarely hook it up to anything with HDMI. I usually always use it in headless mode.
okay,
So I mean, if my computer's on the same hotspot as my Pi, I can just SSH into it
okay.
and access it that way. Or like I told you at the beginning, you can always enable serial connection, log in through serial, and you could interface that way if you have a cable for it. Depending on which one you use. So I mean, if you have the Raspberry Pi Zero, the $5 one that doesn't have Wi-Fi on it, and you haven't added any accessories to it, the SSH over the connecting over the serial is the ideal approach. Because otherwise, how else are you going to connect to it, right?
Yeah.
So basically with that Raspberry Pi, you just do the serial in and serial out, essentially, right?
Yeah, that's what the TX and RS are. Oh, yeah, I don't know what that is.
That's one, just,
Yeah.
So how much free access you get a month from here?
Yeah, from here you get 250,000 transactions per month. So a transaction, in the case of, say, let's say you're using the geocoder, you do one request for an address to a latitude and longitude coordinate, that's a transaction. The map is the only one that's kind of different because a map consists of several tiles. So I believe it's 15 tiles, composes every screen of the map. So that'll change depending on how the user uses your application.
So like when you were driving, how many requests did you use in your app on that?
It's
14,000.
14,000?
Yeah, so not that much. I mean, so I throttled mine. So this GPS.
So 14,000 is how many data per minute?
Yeah, so I throttled mine. So it's gonna spit out a lot of GPS data every second. I throttled it to every 2 seconds.
Every 2 seconds.
Yeah. Otherwise, I don't know what kind of chaos that's gonna create.
The free is what again?
250,000.
Man, so if you just take the data like once every minute, you're not gonna get too many customers.
Maybe.
About 250,000, that's a lot, isn't it?
It is a lot.
And it's free.
Yeah.
It depends on what you're doing.
Yeah.
And I know, but I feel like every minute you get 20.
You can always create bad code and then you burn through that pretty fast, right?
or if you create a service that you're selling to other people, basically.
Yeah, no, I know, but I mean, for
an
checking it out,
Yeah, that's great.
Once you've got a product to sell, then I guess that's what you pay off.
Sometimes you may not even need to, right?
That's what I need, 250,000. Well, that's just one account. If you need to sell to a client, then
Yeah.
So where did you say these slides will be available?
I'm gonna send them to the organizer, BJ, and let him worry about sharing them.
DJ or Marco post on the Discord somewhere.
Are there any companies that are using XYZ that you care to share?
So XYZ, so it was released earlier this year, so it's
Oh, okay.
still very new. But as far as your products go, tons of companies are using your products. So Amazon is a huge customer. I don't know if you've ever ordered something like their 2-hour express or the same day. Generally, they'll show a map and they'll let you track your driver. I don't know. I assume that's over here in LA that you have that feature. I don't think it's everywhere, but that's just some of the client-facing stuff. And they still use it in the background for all their other shipment stuff, though. Still. So here actually has an API. It's called the Waypoint Sequence API. So a lot of companies will use it to calculate the most efficient places to visit first. So if you're a package shipping company, right? You've got 1,000 packages you gotta ship today, and you're leaving from the warehouse. Well, which order should I go to in order to make it back there not 10 years later, right? To the warehouse. So you sort the waypoints using the API, and it calculates based on the distance, based on the traffic conditions, and then you can plan your route appropriately.
You have traffic data?
Yeah, it does have traffic data. So the traffic data, we have vendors for that.
You go make one of those that allows you to do that with a Costco food server.
Yeah.
The optimum, because sometimes you go in and they're running out of food and they don't use one. So
What's the site that you had posted this on?
Yeah. So I actually put it on Netlify. I'm gonna see if I can clean it up. Yeah, I'll give you the link one second here. See if I can reconnect to the system here. Yeah. So I don't know if that's visible. I can read it off if you need it. Yeah.
what was the reason why you're getting this crazy lines like this?
I don't know. I probably have some issue somewhere in my code. I'm gonna reevaluate it.
It looks
I
like
threw it up quick.
It looks like that's all the Starbucks that you visited.
Probably. I took a lot of pit stops. It's a long drive.
Looks like quantum computing calculating all
Yeah.
the possible places you were.
At least it calculated where I left and where I ended up. So I got that far.
So if you track the actual good data, it should just go right along the freeways, right?
It should, yeah.
Yeah,
it should.
that in the final.
Yeah, I mean, we looked here, and you can see that This is a more accurate representation of my writing. As you can see, I don't have chaos going all over the screen here.
Maybe you did a tap group.
Yeah, have an objective.
So those data points that were way off the road,
Yeah.
are those kind of false like GPS locations?
No, because in that circumstance, we would have false GPS locations here. This is the actual data rendered with XYZ.
Oh, okay.
So I don't know what was going on. I'm doing some kind of craziness in that.
So those kind of look like velocity vectors. Isn't it?
Yeah.
Settle.
Yeah, it'll be fixed. And then you can just right click it and view my source code when I'm done. It's up to you.
Well, you get a big bill or a credit card from XYZ, that was good.
Sure. Well then, if there's no more questions, thanks for coming.